All right, everyone, this is part 5 in the series, and for this part, we will talk about Phonokit, which is a new package or library for typesetting phonology, basically. That's something I've been developing for a month or so at this point. But before we get started, I'd like to talk a little bit about the editor that I'm using right now, because up until this point, for parts 1 through 4, we've been using Typst online. So their editor is quite good. It's very practical, but at the end of the day, you probably, if you are to adopt Typst and switch to Typst from LaTeX or whatnot, you will want to use an offline editor, probably. So what I'm using here is Positron, which is just a fork of VS Code. If you use RStudio, R, etc., you already know what Positron is. It's basically VS Code for data analysis. Now, that's probably the main option that you have if you want to use Typst offline, which is to basically just install VS Code, Positron, etc., and then install the extension called TinyMist. Now, it's not the only extension for you to use Typst, but it seems to be the best one, right? So you can just download VS Code, install that extension, or do the same with Positron, and you're good to go. That's what I have right now. And then you can compile the document to preview it on the right-hand side here just by doing Command K and then V. Now you can change all that and get into the details, create your snippets, etc. I myself don't use Positron. I don't use VS Code. I prefer this other option here, which is to use NeoVim with the TinyMist plugin. Same idea. So these are the main ways to use Typst offline, just to give you a heads up. And so this is what we're doing today. We're using Typst offline to some extent because we're using Positron here. Now, at the top of the document, you can see I'm already importing a package, which is Phonokit. It's the package right here. But you can see there's something commented out, and that's the first thing I'd like to talk about, which is how you actually import a package. Up until this point, we were using the @preview / and the name of the package followed by the version of the package : and asterisk, meaning we want to import every single function inside this package. Now, this works, it's fine. It is something that requires you to be online at first so that you can load the package the first time around. So it's kind of different from Python, LaTeX, etc., where you would install the package even before using it, or you could just download a bunch of packages at once, etc. It's kind of different in terms of the architecture. So this is the official way you load a package, preview, etc., right? Now, Phonokit right now is in its version 0.2.0. So that's the version that right now on this day is available online. But the most up-to-date version, which is the version I will be using here to demo the package for you, is 0.3.0, right? But that version is not yet available to be used from the official repository. Okay. Now, it will be. By the time you're watching this video, it's probably already there. But this gives me the opportunity to tell you about these two different ways, because you could just download a package manually and use it locally, which is what I'm doing right now. You could just fork it, you could clone it, whatever you want to do. It's possible to do that locally, and then you can create a symlink and use it right here, right? The only caveat is that depending on how you structure your files, you will need to create a symlink. I go over that in the vignette that I will talk about in a second. In here, you just have to load the lib.type file. That's it. It's basically a synonym for the preview, Phonokit, etc., etc., right? So this is if you want to, if you want to download a particular package and manually inspect it just to learn a little bit about it, or contribute to it, which would be great too. So this is just another way, a little bit more manual, that you can do that if by any chance the package that you want to use or its most up-to-date version is not yet available on the official repository by Typst. Just to give you a heads up. Now, most of the functions that I will be demoing today are already available in the 0.2.0 version that is available right now. but some of them are not. And so it would be nice to kind of show you these two ways of importing a package and using a package just by manually importing it. All right, so the package is already here. You can go to GitHub and you'll find it. The main thing is that everything you need to know about the package is on my website. It's gtgarcia.ca/phonokit. You have a link to the GitHub repository where you can do whatever you want with it. You can also submit issues, etc., contribute, fork, clone, whatever, right? You also have a very comprehensive manual there, a vignette that shows you all the functions and gives you all the references that you need to use the package. That will be much more comprehensive than this video. So here I'll just give you the highlights and show you exactly what the package can do. And the first thing we'll start doing is phonetic transcription, because this is by far the most basic thing that you need to do with Typst. Now, there are some packages already that do IPA transcription, but coming from LaTeX, I've always thought that they are less intuitive. So my muscle memory is already set to the all the references and symbols that we use in the package TIPA for LaTeX. So if you come from LaTeX, you know what I'm talking about, because this is by far the most fundamental package for phonologists or phoneticians in LaTeX. And so what I wanted to do was to create a function in Typst that worked and that used exactly the same references, or pretty much the same references as TIPA in LaTeX. So I'll just give you one example here. So the name of the function is IPA, very easy to remember, and it works just like this. All right, so you will notice here that it's pretty much the same symbols used in TIPA. D, capital D stands for the sound, so the interdental fricative, the voiced one. You have the capital I for the lax vowel. And then for spaces, you use /S. But other than that, it's pretty much the same as TIPA. It works right out of the box, and it uses Cherrysil. So you'll notice here that I'm using Cherrysil for the whole document. You don't have to do that. You can use whatever font you feel like for the document, but the package itself uses Cherrysil. If you don't have it installed, it will fall back. It's not a problem. It will throw you a warning. It will work. It's just not going to work exactly the way it was intended to work, because it is intended to work with Cherrysil. So if you use the typst.app online editor, that will give you a warning because this particular font is not installed in the online version. That's it. Now, of course, you could do square brackets or slashes in here. You know, it works as intended, basically. So this is the first thing, IPA transcription. It's very easy. There's a bunch of examples for diacritics. There's a reference page on the website. You can check the vignette. Again, everything that I say here is going to be a summary of the function. So if you want to know a little more about it, just go to the vignette. All right, so is it as comprehensive as TIPA? It isn't, right? Because my idea initially was to create a function that does all diacritics and all phonemes that I need, and that is a subset of all the diacritics and phonemes. So there's a bunch of things that are not there, but of course you're welcome to suggest additions and to add stuff yourself if you fork it, and that's kind of the whole point. All right, so that's the first thing. The second thing about the IPA module involves inventories. So you can do vowels and consonant inventories very easily. So you could do something like there's a function called consonants, and inside you could just do English, for example, and it will add a consonant table with all the English consonants. Now, there are some caveats here. You can add affricates or not. So this is trying to emulate the actual official IPA table, which doesn't show affricates here by definition, but you can add that. There's an argument in the function that allows you to add these things. So there's a handful of languages that are already pre-built in the function, like Portuguese, Spanish, Italian, I think. So the list is in the vignette. The same thing works for vowels. So you could do vowels in Spanish, and you will notice it will add a vowel trapezoid for Spanish. Now I'm just adding the functions. These are not technically figures that you can refer to. If you want to know how to do that, just go back to one of the videos from parts 1 through 4, where we talk about wrapping things with the figure function. So it works as intended like that. There's also a function called grid, which I can't remember if we talked about, but it's super useful to organize figures and tables and columns, etc. Super nice. You can Google it. All right, so this is the IPA module. This was technically possible in LaTeX already. Of course, you have the vowels package in LaTeX that does something like this. It's much more convoluted. The way you use the package, it's much harder. The nice thing about vowels and consonants here is that you could technically just add a bunch of vowels in here, like I, U, and A. So I, U, A, for example, will just print the string in the trapezoid. And the same thing works for consonants. And it accepts the same types of symbols and references used in the IPA function. So if you wanted to add, for example, the schwa, you would do the @ sign, and it adds the schwa right where it belongs. Right? So it's much, much quicker to use than the equivalent vowels package in LaTeX. I don't know if there's a consonants package. I don't think there is. So you could just do a table with the consonants, but it's very time consuming. Tables in general in LaTeX are extremely time consuming, as you know if you use LaTeX. So this is just kind of a quick way to create these inventories. One other thing is you can add a scale to the function. So you can scale it down, for example. I think by default it's 0.7 or something. So you can just go up and down as needed, right? So 0.7 is the default. If you needed to make this much smaller, you could do 0.3, for example, and it scales down correctly as intended. So I'll just remove the scale argument here. So this is the IPA module. It is partially possible to do this with packages that exist in LaTeX. It's not exactly the same thing, but the idea is to have something that is much more intuitive and quicker. Now, for the Prosodic module, there's a bunch of things that I personally couldn't do with LaTeX in a quick way. So if you've used LaTeX, you know there's this package called Typst, which is extremely useful and super powerful, and you can do all sorts of structures, nonlinear structures with it. Now, it is a little tricky to learn how to use it. The learning curve is pretty steep. And so the goal in the Prosodic module was to create prosodic structure, prosodic representations with a Typst style design. So the package that kind of this function depends on, or these functions depend on, is called sets. I think that's how you pronounce it, which is kind of like Typst for Typst. And so that's the dependency that the package here, Phonokit, uses for a lot of what it draws, basically. So the Prosodic module contains a bunch of functions that are very easy to use and that create specific prosodic representations. So for example, if you wanted to create a syllable like the syllable P, I, and T, you can see here, it just does that, right? It recognizes the onset and the nucleus and the coda, and it just prints the syllable structure on the page. Very easy to use. The same thing can be done with the mora function. So I'll just do the same syllable here. You can see that by default, the coda doesn't project a mora, but you can change that, as you can see here, by using the argument coda : true. So if you do coda true, now the T also projects a mora and you have a heavy syllable. Okay, so again, this is just something that is very quick to do and would take a while to draw. If you use Microsoft Word, it doesn't really matter what editor you use. I've spent so many hours producing these types of representations that, you know, this is just a function that makes your life easier. So that's for syllables, but you also have the equivalent for feet. So you can do foot and then do something like this. So again, very easy to use. If you wanted to have a right-headed foot, or by default, it's going to be a trochee, but if you wanted to make this an iamb, you just use the apostrophe, which is the diacritic used in the IPA function for stress, and now you change the headedness of the foot. Now, there's also the equivalent for Moraic theory, so you can do foot mora with a hyphen in between. That function is also discussed in the vignette, so you can just take a look at that if you're interested. And finally, there's word. It's probably the most important function here, because the function word creates a prosodic word, and you can use brackets and diacritics for stress to represent feet and headedness, respectively. So you could do something like this. Something like that, for example. So this is a word that contains a trochee and an unfooted syllable at the end, and that's read correctly. You could change this into an iamb, again, just doing that, and now you have this kind of the same structure, but the headedness is different. There is also an option for Moraic representations in this function. You can take a look at that in the vignette. Okay, so this is the prosody module. And honestly, I think this is, to me, the most useful module, because I do these representations all the time, and they are really time-consuming to produce if you're doing things manually. Next thing, there's SP-related representations. This is probably the easiest one, because you don't really need anything special for SPE rules. If you are able to produce matrices and arrows, you're halfway there already. And these are all functions that are available out of the box, regardless of what if you use LaTeX, it's the same thing. Plus, there is already, and I think I mentioned this in a previous video, there's already a package for Typst that does SPE rules, and it's a very good package. So here, this is going to be less convoluted. It's just a module that contains, I think, two functions, the first of which creates a feature matrix for a particular phoneme. So let's say I want to do the matrix for the vowel a, and this is the maximal matrix for that vowel. So kind of useful for teaching and printing sequences of matrices in a handout or something like that. So it's just a quick and easy way of producing these things. Now, of course, a lot of the times you actually want to produce a rule, and for that you could do something like this. You could just do the feet, which is a function that creates the feature matrix. Then you have some helper functions like a-r, which creates this arrow using a different font. I think it's Computer Modern or New Computer Modern, if I'm not mistaken. And then you have, alpha place with small caps and all that. So, this is pretty straightforward to do. So the only thing that the module is doing is helping you reduce the number of things you have to type to create a rule like this. So that's the SPE module. Now, the OT module does something that is, in my opinion, more useful than that, because, again, we're talking about tables this time, and every time you have to produce tableaux and tables, it takes a while if you use LaTeX. And even if you use something like Microsoft Word, it is a little annoying to format the tableau the way it should. Plus, you have to shade some cells, you have fatal violations and all that. Now, let me just give you the example here. There is a function in Phonokit called tableau, very intuitive, and it works like this. It's just a function that has a series of arguments starting with the input. You can see, again, it accepts the same symbols that IPA does. So you can use capital T for the th sound, for example, and that works out just as intended. The input is always surrounded by slashes by default. Then you have the candidates, which is just this array here. You have 3 candidates, so you have 3 rows automatically adjusted. You have 3 constraints, and then you have the violations here. So you have to manually insert the violations and add exclamation marks whenever there's a fatal violation. But the nice thing is when the function detects an exclamation mark, it will gray out the remaining cells in that row automatically, so you don't have to worry about that. Then you have winner, which indicates which candidate wins starting from 0. So if it's the first candidate, you just do winner 0. And finally, you have dashed lines, which allows you to decide which of the columns will have dashed lines because you don't have a ranking argument. So again, very intuitive to use, and it does a lot of things automatically. It also scales down and up as needed, which is kind of nice. Of course, you could do that just by changing the font size before the tableau as well. And the final module, which is kind of, this is already the final module if you put MaxEnt and OT together. But before we talk about MaxEnt, there's something that we often see and do, which is a diagram, a Hasse diagram to show constraint interactions and rankings in a nonlinear fashion. And you can do that with the Hasse function. So Hasse here will just take tuples, and inside you will just say which constraint dominates which constraint. The number indicates which level of the representation you want to use for that particular relationship. So you can also do floating constraints by leaving just a single constraint inside without a position in that tuple. So you can see it's relatively straightforward to create these types of diagrams as well. If you look at if you check the vignette, you will see that there's a convoluted example there where you have a bunch of constraints. So it looks a little better to kind of see what the function is doing for us. And finally, the MaxEnt module allows us to create a tableau that is in the correct format for a MaxEnt grammar. Now, the nice thing about the function MaxEnt is that it calculates harmony values, the exponential to the negated harmony value, and the probabilities automatically. So once you give the function the candidates, constraints, and weights, and the violations, it will just calculate everything for you. So in a way, it's kind of it's as if you were using Microsoft Excel inside Microsoft Word if you use Microsoft Word. And of course, there's this extra at the bottom here, which is useful for teaching purposes, which is a visualization of the probabilities for each candidate. Of course, you could just turn this off, and that would give you a typical MaxEnt tableau. But if you wanted to show students how, let's say you have a bunch of candidates, it is kind of nice to see the probabilities in a more visual way, and the tableau does that. And again, it scales up and down depending on how many constraints you have. Of course, if you have a ton of constraints, it's going to have to be small enough to fit the page, etc. So that is always something to consider regardless of which tool we use to produce these types of things. All right, so these are the main functions in the package. And again, in the vignette, you have a lot more information about which function does what and how to use the functions and all the arguments. There's also auto-segmental phonology. So if you want to do spreading, delinking, floating tones, that sort of thing, it's also possible with the auto-seg function. Examples in the vignette. And of course, this is a very recent package. It's probably like a month old. So it will improve the existing functions and hopefully also add some functions in the near future depending on feedback. So that's why I welcome feedback in the repository on GitHub, which is linked on the web page or homepage for the extension. So this is it for part 5. And thanks a lot for watching.